So, energy efficiency in building design is obviously central to your work. And what trends are you seeing in how project managers and engineers are approaching energy modeling today?
We really need to look at any and all solutions to get there. And it's kind of nice because some of the building owners and architects, they make that, one of the priorities at the forefront. They want to have a sustainable and resilient building.
Did you know that energy modeling has evolved from a behind-the-scenes technical task into a strategic tool that project managers can use to deliver smarter, faster, or more sustainable outcomes? In this episode, I'm joined by Matthew Duffy, Vice President for IESVE Sales for North America East at IES, to discuss how energy efficiency is reshaping project delivery. We'll talk about the latest trends in energy modeling, how digital tools like IESVE can help balance cost, performance, and sustainability, and why stronger collaboration across disciplines is key to project success. If you want to stay ahead of client expectations and evolving regulations while delivering real value to your projects, this is an episode you won't want to miss. Before I jump in, I want to tell you about our AEC PM Connect Event, built for project managers who want to improve project delivery, communication, and leadership through practical successions and tools. These events provide an avenue to connect with leading PMs in the industry. Visit aecpmconnect.com and register today. We currently have events in Kansas City and New Jersey, with more coming. I'm your host, Fiona Johan, and this is the AEC Project Management Podcast. Let's jump right in.
Before we get started, here's a word from our sponsor for today's episode, School of PE. Are you putting off preparing for licensure? Waiting for life to slow down so you have time to prep? Months from now, you could find yourself still waiting for the right time. Or you could start preparing today with School of PE. Take the guesswork out of exam prep. With 93% pass rates, expert instructors, and a pass guarantee, you'll be walking into that exam fully prepared. Make the right choice today. Enroll now and save 32% with promo code EMI32 at schoolofpe.com. That's SCHOOL of PE.com.
All right, now it's time for our PM Conversation of the Week with Matthew Duffy. Thank you so much for being here, and welcome to the Engineering Project Management Podcast.
Thank you, Fiona. I really admire what you folks are doing with these podcasts, and I'm delighted to be here.
Awesome. Well, let's start, if you could, just walk us through your journey from mechanical engineering into your current leadership role at IES.
Yeah, IES, we are a sustainable software solutions company that's primarily making software for the AEC industry, for engineers and architects to analyze buildings. And that might be doing load calculations and HVAC equipment sizing, and it could mean anything from energy modeling, code compliance modeling, or some type of green building modeling. Now, how I got here is a long story that started with my brother dropping a nitrogen tank on his foot.
I'm excited about this.
Yeah, and it was the summer, I think the first summer I was in college. I was doing odd jobs around the campus of the Milwaukee School of Engineering, where I got my undergrad in mechanical engineering. And my brother was a gopher, a parts gopher, go for this, go for that, at my uncle's HVAC company. And so when he broke his foot, it introduced me to the HVAC industry, specifically more on the commercial side. And that kind of opened the doors and my eyes to the HVAC industry and the opportunity to make it better, because the building sector consumes approximately 40% of the energy, at least here in the States. and more than the transportation industry. So I felt that was near and dear to my heart. So I narrowed in on HVAC, energy, thermodynamics, and heat transfer.
Wow, I like that a broken foot brought you here today. You never know. You never know how you're going to get where you're going, but that was a little sparking event. That's wonderful. Well, so that actually didn't know that 40% statistic. So that's a really good, it's a little good tip to have in the back of your head for when you have interesting facts to come into a conversation with. And can you talk about, as a mechanical engineer, now that you are in a leadership role, how has your technical background influenced the way you approach business strategy and client engagement in the AEC industry?
That is an excellent question because obviously with the engineering background, it's highly technical, very calculated, very analytic, right? So that background has taught me to be able to speak that language to anyone on the project team really, and to understand the goals and kind of the strategy and the communication style of these different folks. So I I really like talking to different engineers and different project managers on the team, because they can not only speak these different languages, but also the other languages that are near and dear to the hearts of the building owners, the architects, and everyone else involved in the project.
In the AEC industry, skilled project managers are the backbone of success. EMI's AEC PM Certification offers tailored training, ongoing support, and exclusive access to premium content that keeps your team sharp and effective. From foundational training to advanced leadership tools, set your team apart with certified growth. Learn more at aecpm.com. That's aecpm.com.
So, energy efficiency in building design is obviously central to your work. And what trends are you seeing in how project managers and engineers are approaching energy modeling today?
It is not only, looking at energy efficiency and energy efficiencies of the whole building, but it's also looking at the different layers and the different aspects of energy efficiency or carbon. Sometimes that phrase is used synonymously with energy efficiency. And I really admire the other week you folks had a geothermal expert on your pod, and we really need to look at any and all solutions to get there. And it's kind of nice because some of the building owners and architects, they make that, one of the priorities at the forefront of their project. They want to have a sustainable and resilient building. And to do that, we need to look at all of the energy flows going into and out of the buildings. Where are our heat sources? Where are our heat sinks? Where, the site energy, the source energy, the CO2 emissions, other, greenhouse gas and global warming potential of all of the different products and systems that are going into these buildings to make, to check all those boxes for the building owners and the architects and the project managers and everyone moving that along. And looking at all the different scenarios, all the different systems requires us to get very intimate with the location, the site. And that's like, thanks again for having the geothermal folks. That works really well in some climates and areas and different soil and bedrock types. In other areas, it does not. So how can we, look at these buildings holistically to ensure that we are meeting these energy efficiency carbon goals and still moving the project along and on budget at the same time too?
Well, I think you hit a few key things there. There's a lot of different pieces to consider and look at, and firms are under pressure to balance cost and performance and sustainability. So, how can digital tools like IESVE support better project decisions while also reshaping the responsibilities of project managers?
Yes, this is where my passion lies, because the sooner that we can incorporate the analysis from these digital tools, from these building analytical modeling and performance tools, the sooner that we can incorporate the results of this, the more likely that they will be implemented in the project. And it takes a lot of effort to drill a bunch of bore fields and hook up all the pipes for a heat source and heat sink for a geo exchange system. However, what if we can do that virtually, on a computer model with your building design? What if we understand that, the people coming in and out of the building, turning the lights on, we understand the required air ventilation rates. What if we put that in a virtual model? And then, maybe we could test out a geothermal system. Maybe we can test out a more traditional, VAV system, a variable air volume. There's a lot of different acronyms thrown around in the industry, of course. But the ability to do this in a virtual model and not only look at, all right, what is our worst case scenario in the summer and in the winter, looking at, the load calculations and the HVAC design, but what if we just click a few more buttons and analyze an annual energy model and see how it will perform, how much energy it will consume, how much carbon emissions this will have. In a matter of minutes or hours, we can get that data to the table, to the design, the design table, the design charrette, and see. So these virtual models are becoming extremely valuable, especially as we can incorporate them early into the design phase to meet the project's sustainability goals.
Sounds like it would actually give people a lot more room to be creative since you can run so many different situations, which is always nice.
Yeah, and you can start looking at quickly looking at different systems. When I worked for the large MEP company, we did high performance buildings, hospitals, laboratories, mission critical, and we were always considering, are we going to do a full-blown system with the huge ductwork, or is there opportunity to look at different systems? Maybe active chilled beams there. We can really scale down our ductwork and save the building owner of this huge project a lot of money in steel required to go in there. So we can not only look at different systems for energy performance, but at the same time we can look at the embodied energy, carbon, and costs at analyzing different systems to see maybe it will cost less here, and we can trade off with a little more cost here on the systems.
That sounds like a super powerful tool in the hands of an engineer. So, what should PMs know about load calculations and HVAC equipment sizing software? We kind of started to touch on that. So, what should they know?
So we are in a transition in the load calculations and HVAC equipment sizing. The industry standard, including the software that I learned on in undergrad, it was more of a two-dimensional model. It made it a little difficult as an educational tool because we can't really see what's going on entering. But now we have the ability to use a full 3D model, and this gives both the user and management an advantage in a few different ways. By using a full 3D model, one, you get more accurate calculations for your load calc in HVAC equipment sizing because it understands the geometry, the radiant energy exchange with all the view factors of the different surfaces. Two, it also provides the opportunity to QA and QC the inputs, quality assurance, quality control for management, for the project managers to quickly, in a matter of seconds, with input data visualization on the 3D model, they can look at and see what templates have been used. Is it, an office space? Is it Is it a laboratory space? Is it, a patient room? They could quickly look at the templates. They could quickly look at the different constructions. They could quickly look at the scale of the different internal gains. Talking about the electrical lighting, the equipment, the occupancy of the different people. So whenever I'm teaching the software to management, I say, like, this is the easiest low-hanging fruit that you can incorporate into your practice to quickly see that you have good or bad inputs going into this model. So that's input data visualization with a full 3D model. Then you can also use that on the output side as well. You can render your different results to your model, and this creates a very effective communication tool to anyone. Traditionally, us engineers, we like to speak in spreadsheets, and that may not bode well for some other types. So the ability to take this full 3D model and take your output results, off the top of my head, I'm thinking of like a cooling load density, and we can visualize that and render that on your 3D analytical building performance model to see, oh, okay, this space off to the east here, or this space off to the west, it is much, much brighter on this color-coded scale that tells me that this space has a lot of gains, whether that be internal loads or a lot of solar gains, the incoming sun through the windows. And maybe there's something that we can incorporate there. Maybe we could ask the architect, hey, can we incorporate any exterior shading devices, really bring down that thing? And in turn, by doing that, we could say, hey, we could really decrease the cooling load such that we don't have to get another terminal unit in this space, that we don't have to size our chiller up another space, and we could really save a lot of money for the building owner for this from a 3D model. So that's why I'm so excited that in this industry, we're transitioning from the old and outdated, less accurate load calc and HVAC sizing model to a full 3D model.
Really sounds like these 3D models are offering a really good chance to collaborate across disciplines, right? Especially on challenging projects. And you touched on it a little, but how else do you see energy modeling bridging the gap between design, engineering, and project management teams?
Yeah, there are ample opportunities, and there's still opportunities available for the design and project management teams. One that comes to mind, where we're still always looking at ways to get better and more efficient, such that we're not tinkering and prone to error, but that we can, as an analyst, spend time doing what we're good at. Looking at these different interconnections of the building and the team. So, what comes to mind there is working with the BIM model, the building information model, and how can we get data to and from the BIM model, the interoperability with our software. Right now, there is a really neat plugin that can take your BIM model, whether that be in Revit or Rhino or SketchUp, and bring that geometry, that 3D geometry, right into our analytical software platform. And that plugin has worked very well and has saved teams a significant amount of time to bring that 3D geometry into the model. And also, with the interoperability, we could also export other things back to the BIM model, whether those be the different volumetric flow rates, the CFMs for the different spaces. CFM is cubic feet per minute, or the loads in the space, bring those back to the BIM model.
Great. Around that, what do you think, you talked about how we can use it effectively. What do you think some of the biggest misconceptions project managers or engineers have about these, like, energy modeling, and how would you typically address them?
Yeah. Oh, I think one of the biggest misconceptions out there is that they're either too clunky, too resource intensive, and that it takes too long to get decent results back. Like with these analytical tools, I can get relevant results in a matter of minutes. I mean, obviously that's based on my comfort level with the software and a lot of experience there. But users and engineers now, and even project managers, like if I was in more of a project management role and I was mentoring some folks on my team, I would easily say, hey, you know, is there any opportunity we can just analytically just look at one of these spaces, one of these common spaces, the office space or one of these patient rooms, but I want to look at it on every angle. I want to vary the window to wall ratio. I want to vary, the occupancy densities. And could you just quickly do that, set that up for me and color code the outputs for me? Someone could do that in a matter of minutes or an hour to have really, really good, insightful data, perhaps to the architect or the building owners onto the, in this case, it might be cooling low density or heating low density, to keep it under a certain level such that this this system could still adhere to this specification or the specific part of the project goal. So back to your original question, I think analytical building performance software is underutilized, underappreciated, and kind of misunderstood in how incredibly useful and insightful it can be, even just for a little analysis here or there.
I heard you say, we're talking about how people, what they might not know about it. Do you think it's the initiation energy? Like it's a daunting task to worry about the inputs and therefore they revert back to what they're used to?
Yeah, there's a learning curve with it, because not only you have to understand all of the building physics, all of these energy flows and into and out of the building, but the user needs to understand, all right, how do I input all of these things into the building? And great metaphor that I like to think of is I recently started this outdoor activity of fly fishing. And there's a significant learning curve to fly fishing. There's just so many different factors, so many different inputs, and also the motion of trying to fly cast, which is extremely different than regular spin casting. So it does take some time, and hopefully it you can position yourself around excellent mentors or excellent training material to get over that learning curve. And then once you are comfortable with that, and back in reality here, it's the inputs and outputs to the building performance model. You can really produce some significant results and add some significant value to your project team.
It almost sounds like, when you have a new employee and, training them feels like it's going to take forever. But if you train the software, then down the road, you're not spending all that time doing all those things.
Yeah, and if I may add to that, we at IES are kind of changing our training model to have a more a project mentoring
Awesome.
aspect.
That's
Yeah, so now instead of a stock training things, which still works for some folks, it still works really well for some folks. We can guide some teams through a particular project, one perhaps an example building that they have. We can guide them through that from the geometry stage to all the different inputs and the systems, and then show them the outputs. And we are finding that this project-based training or project-based mentoring seems to stick quite well with these folks.
Yeah, project-based learning is always obviously as someone from EMI who specializes in learning and development, project-based learning can't be beat. When you get to dig in and actually do something that applies to your day-to-day, it's going to stick harder than anything else. Around that, what piece of advice would you like to share with project managers who are striving to integrate sustainability and efficiency into their projects?
I would love to be able to communicate to these folks that there are so many opportunities early in the design phase, even if we don't know what the architect's geometry is going to look like. If we can simply know the location or the or the city block that this building might be on, that is enough to get these analysts started. With the software that I utilize here, IESVE software, we can link directly to OpenStreetMap. So we can go to a specific block. We can import the surrounding buildings so we can have all the adjacent buildings, shading and start to look at. There's a schematic geometry wizard. So if we don't quite know what the building shape or footprint is going to be like, that's fine. We have a lot of different shapes or footprints that it could be, and we could still run through the analysis, and there's still excellent and informative outputs that we can look at. Different factors, the size of the systems, lighting and daylighting, and the energy use intensity of the building, and we can really help tell the story of the design and conception process and provide a lot of meaningful results as early in the design as possible.
That's amazing. I think one of my biggest things as a project manager is that a lot of us don't spend enough time in the project planning and initiation phase because it's not where we immediately see results. That you do see results if you look at it holistically, but that's not where we get those immediate hits of like, oh, we did it, it's done, we can move on. And it's so great that you have something that can really help you noodle around in that vague area. That's a great place to start and build from. From there, we have our final question. So we call this the PM Pitfalls question. And what do you think is the biggest PM pitfall that you've identified, and how would you recommend overcoming it or avoiding it for PMs out there?
One of the largest pitfalls that I see from PMs is the back of the napkin rule of thumb apply to buildings. And I have a story about that too. So, which is also not to say I don't appreciate I don't not appreciate. Obviously, we really appreciate all of the wisdom that the experienced PMs bring, and they can quickly understand a lot of different things. But sometimes when it comes to building performance and analysis, especially with load calcs and HVAC equipment sizing, it's sometimes the back of the napkin calculation. What's the square footage of the building, and they'll just throw that in and have this. Usually, it's massively oversized system that's never going to reach that full capacity of that system. And that's, oh my gosh, that is one of the things that irks me a lot. And especially since, in a matter of a few hours, we can get a really, really accurate calculation. And the story I'm going to tell is last summer in my house here, in this, modest house here in the Midwest, the air conditioner went out. So I was like, all right, this is an opportunity to have a high efficiency dual fuel heat pump that's operating in either heating or cooling mode most of the year. So of course, I'm like, I'm gonna do my own sizing in my software, IESVE, even though we're traditionally a commercial building software, but it can definitely do all the physics for residential buildings. So I put it in there, and I got 5 different quotes from different contractors, and they were all upsized about 50%. They all said, 3 tons, 3 tons, 3 tons. And even with a small modest house, even with the inputs, I think I put like 14 people in the virtual model here, and it's still only peaked at about 2 tons. So by using the software, I was able to save my system 1 extra ton of cooling and a significant amount of money on that side too, because these folks were using the back at the napkin, rule of thumb calculations that was not nearly as accurate as a modern building performance and analysis tool.
Did you tell him you had done your analysis before they gave you your quote?
Oh, absolutely, absolutely. And like they were they were happy to go with a smaller unit, and it has been working. We're working well ever since.
That's awesome. Well, thank you so much for joining us today. This has been a wonderful conversation. I've learned a lot. Hopefully our listeners feel the same. Is there anything else you want to impart on other PMs before we head out? No pressure.
I just really want to thank you for taking the time. I really admire all the folk, all that you do at EMI with the really interesting guests and podcasts that you have.
Thank you so much. We really appreciate that.
All right. Thank you, Fiona.
Thank you. Please remember, you can find the show notes for this episode at aecpmpodcast.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you all the best in your engineering project management endeavors.